Hello students, in this session we are going to learn about nuclear chemistry. Nuclei of naturally occurring heavy elements like uranium, thorium, radium and polonium are unstable and keep on emitting spontaneously invisible rays or radiation like alpha, beta or gamma rays and give more stable elements. These elements are called radioactive elements. The property of emitting these rays is called radioactivity of the elements. What is radioactive decay? It describes how a nucleus spontaneously breaks down emitting radiation. The rays emitted by the radioactive element are called radioactive rays. In balancing a nuclear equation, it is important to remember that the sum of all the mass numbers and atomic numbers given on the upper left and lower left side of the element symbol, respectively, must be equal for both sides of the equation. Now let's look at this example for unstable radioactive radon-222 disintegrating into an alpha particle and a stable polonium-218 nucleus. The sum of the atomic numbers on both sides of the equation are the same. If you look at the atomic number for radon, it is 86, and if you add the atomic number of helium 2 and polonium 84, it is also 86. The sums of the mass number on both sides of the equation are also the same. The mass number of radon is 222 and that of helium is 4 and polonium is 218. So 218 plus 4 gives 222. In an alpha decay, when a radioactive element emits an alpha particle, the mass number of the stable element is decreased by 4 units and the atomic number is decreased by 2 units. In this example, radioactive uranium-238, it is disintegrated into stable thorium-234 nucleus and an alpha particle. 2 protons and 2 neutrons are emitted as alpha particle in this decay. Moving to the beta decay, when a radioactive element emits a beta particle, atomic number is increased by 1 unit and the mass number remains the same. In this example, radioactive carbon-14 nucleus is disintegrated into a stable nitrogen-14 nucleus and a beta particle. Here, in this decay, a neutron changes to a proton and an electron is emitted. Positron decay. Nuclei that have too many protons for stability often decay by changing a proton into a neutron. In this decay mechanism, a positron is emitted. Positron, it has the same physical properties as an electron except that it has 1 unit of positive charge. When a radioactive element emits a positron, the atomic number is decreased by 1 unit and the mass number remains the same. If you look at this example, fluorine 18 nucleus is disintegrated into stable oxygen 18 nucleus and a positron. Few other examples are also shown here. Gamma decay. Very often, a nucleus that undergoes radioactive decay is left in an excited energy state. The nucleus can then undergo a second decay to a lower energy state by emitting photon. Photon emitted in that way is called gamma rays. There will be no change in the atomic number and the mass number in this radioactive decay. Here we have an example of plutonium-240, which is in the higher energy state that will be disintegrated to form plutonium-240 in a lower energy state. Here gamma radiation is being emitted. Another example is for technetium. Technetium-99 will be disintegrated to technetium-99 with lower energy state and a gamma ray. Now let's summarize what we have learned so far. If the radiation source is an alpha emitter, the new element mass number will be decreased by 4 and the atomic number will be decreased by 2. If the radiation source is a beta emitter, the new element mass number remains the same and the atomic number will be increased by 1 unit. If the radiation source is a positron emitter, then the new element mass number, it remains the same and the atomic number will be decreased by 1 unit. And if it is a gamma emitter, stable nucleus of the same element will be formed where the mass number and atomic number remains the same. Now let's try to answer this question. Write the balanced nuclear equation for the bombardment of nickel-58 by a proton, which produces a radioactive isotope and an alpha particle. First, we need to analyze the problem. What is given is proton bombardment of nickel-58, and we need a balanced nuclear equation. We need to connect the mass number and atomic number of new nucleus first. The first step, write the incomplete nuclear equation like this. 1 proton plus nickel-58 giving a new nucleus plus alpha particle. In the second step, determine the missing mass number. You take the sum of the mass number of proton, that is 1, and nickel-58, that is 58, which gives 59, and you subtract the mass number of alpha particle, which is 4, from 59, giving 55, which is the mass number of the new nucleus. In the next step, you determine the missing atomic number. You take the sum of the atomic number of a proton, which is 1, and nickel, which is 28, that gives 29. Now you subtract the atomic number of alpha particle, which is 2, from 29, giving 27, and that will be the atomic number of new nucleus. In step 4, we need to determine the symbol of new nucleus. In the periodic table, the element that has atomic number 27 is cobalt. The nucleus of this isotope of cobalt is written as 27 cobalt 55. Now we can complete the nuclear equation, that is 1 proton plus nickel 28 giving cobalt 27 plus alpha particle. Thank you for attending this session. See you in the next one.